Okay. In our last class, we were looking at the basis for fundamental quantities and derived quantities. One of the major challenges I faced in creating this second video is that there were constant mistakes because I was missing some terms. But let's go again. So, in our last class, in our last video, I gave us these quantities to go and find their dimensions. So, we're going to do them together one by one. So, the first thing that we have there is momentum. First thing that we have there is momentum. Formula for momentum is mass times velocity. Dimension for mass is given by m, and the dimension for velocity is lt minus 1. Putting that all together, we have mlt minus 1. So this becomes the dimension for momentum. Now, how do we get the derived unit? Mass is given in kilogram, length is given in meters, time is given in seconds. So this becomes the dimension for momentum. Okay, let's try the second one. Let's try viscosity. Viscosity is an area in fluid mechanics that is very essential, and this is the symbol of viscosity. This is the symbol of viscosity. Now, viscosity is given by the force times the radius over the area times velocity. So this area is very essential in engineering and fluid mechanics, which is an expert in physics. So this viscosity can be defined as the rate of resistance to the flow of a fluid, or this can be defined as the friction that exists in fluid. Take for example your palm oil. If you are turning the palm oil, you'll notice that it's going slow. That's because there is a rate of resistance to the flow of the fluid, and that is known as the friction in fluids. So the friction in fluids, when we are talking about fluid, we are talking about liquids, is known as viscosity. Now this F here stands for force, this R here stands for radius, V here stands for velocity, A here stands for area, and force is given by mlt minus 2, radius is given by L over A is given by area, L to the power of 2, velocity is given by lt minus 1. So putting everything together, we have mLlt minus 2 over L raised to the power of 2 lt minus 1. So from there we have that this is multiplying each other, so we add the powers. ml1, this is 1 and this is 1, plus 1 t minus 2 over L to the power of 2, so this is 2 and this is 1, plus 1 t to the power of minus 1, so that is equal to ml to the power of 2 t to the power of minus 2 over L to the power of 3 t to the power of minus 1. So let's see how we can simplify it further. So I'm going to come up here and continue. So we have that this over, I told you is divide. In our last video I made reference to this, that this is divide. So this is ml2 t minus 2 divided by L to the power of 3 t minus 1. So breaking it down, that is ml2, divide stands for minus 3, and t minus 2 minus 1. So that is equal to m2 minus 3, that is giving us minus 1, t minus 2 plus 1, minus 2 plus 1 is equal to ml minus 1. So minus 2 plus 1, if you look at it, minus 2 plus 1 is going to give us minus 1, because now the bigger number is having the negative sign. So therefore, the smaller number is subtracting the big number to give us a negative result. So this is the dimension for viscosity. What then becomes the unit? So from here, mass is in kilogram, length is in meter, and time is in seconds. So this is the derived unit that we have. So let's come over here Let's go to the third one. So the third one that we have there is the moment. And what is the formula for moment? Force times distance. So from there we have that force is equal to mlt minus 2, that is mass times acceleration times distance L. Putting everything together, we have mll t minus 2. You notice that moment is like work done, so that is equal to m L1 plus 1 t minus 2 equal to m L to the power of 2 t minus 2. So this is dimension for moments. Mass is given in kilogram, length is given in meters, and time is given in seconds. So let's go over to tension. Let's head over to tension. So for tension, we have force over area. Now you notice something, that this tension is looking like that of pressure. So force is mlt minus 2 over area, L to the power of 2. So that is mlt minus 2 divided by L to the power of 2, and that is equal to ml. So this is 1 and this is divide, so that is 1 minus 2 t minus 2. So that is equal to 1 minus 2 will give us minus 1, then we have t minus 2. So mass is given in kilogram, length is given in meter, and time is given in seconds. So for period can be used in different contexts. Period can be used in the context of simple pendulum. Period can be used in the context of wave and vibration. Let's try it in the context of wave and vibration. So for wave and vibration context, the period is equal to 1 all over the force. So the period is given in T, 1 over force. Force is given in mass times acceleration, which is mlt minus 2. And that is equal to, so now we're taking everything upwards, m minus 1, L minus 1. Now this one is having a negative sign initially. So when it's going up, it will have a positive sign. I told us in our last video that according to the law of indices, that is what will happen. If it's having a negative sign as the denominator, to become positive sign as denominator to become negative. So that is equal to mass is given in kilogram, length is given in meter, and time is given in seconds. So this is it. So we'll be able to do the work I gave from our last video. So today we'll look at something, application of dimension. Now one thing we need to take note of under this application of dimension is that dimension, they help to derive new equations. Now the importance of dimension is that they are used to derive new equations. They are used to check the correctness of an equation. Dimensions are used to check for the correctness of an equation. Dimensions are also used for solving mathematical problems. But the disadvantage of this dimension is that they do not recognize numbers. So if you put a wrong coefficient inside the equation, dimension will not be able to tell if it's right or correct. Dimension, they are not recognizing numbers because why? Numbers are dimensionless. Now let's look at a major application of dimension. Now given this simple pendulum formula for period, t is equal to 2 pi square root of L over G, we are told to derive using dimensional analysis. Now applying dimensional analysis, you notice something here. This 2 pi is dimensionless, and so we don't consider the 2 pi. Now this period there is depending on two things. Period there is depending on the length, and also is depending on the acceleration due to gravity. Those are the major two things that the period there is depending on. Now aside that, if you remove this proportionality sign, a constant will be formed. So t will be equal to k, and the powers will have a variable. They will bear a variable, L to the power of x and G to the power of y. So the period is equal to k Now this is length, remain like that. Now g is acceleration due to gravity. The formula for acceleration due to gravity is given by Formula for acceleration due to gravity is given by LT minus 2. So we have y in brackets. So from there, we have that T is equal to K. Let me write it neatly into LT minus 2. That is for acceleration due to gravity. So now T is equal to K L raised to the power of x. Now this power is affecting everything in the bracket. So we have L raised to the power of y and T raised to the power of negative 2y. The y affected both. The power here is 1, the power here is 2 minus 2, that is 2y. So now let's collect coefficients. So that is k L to the power of x plus y, then t to the power of minus 2y. Now what are we going to do? We are going to compare the left hand side and the right hand side. Now we'll start with the first variable here, the first quantity here. First quantity here is length. So looking at the left hand side, there is no length. So for the length coefficient, so we'll come here and say comparing coefficients. Now comparing coefficients for the length. So length here, there's no length here, so we'll say is L raised to power 0, L raised to power x plus y. So this L is going to cancel out this L. So x plus y is equal to 0. We're going to call this one equation 1. So let's go for the t coefficient. Now for the t coefficient, we have that the t here is 1. So t raised to the power of 1 is equal to t raised to the power of minus 2y. So this will cancel this. So this is going to cancel this out. So we are going to be having minus 2y is equal to 1. Now dividing both sides by the coefficient of y, minus 2y over minus 2 is equal to 1 over minus 2. This will cancel and y is equal to minus 1 over 2. Now we'll say put y in equation 1. Now putting y in equation 1, let's go back. So this is our equation 1. So equation 1, we have x plus y equal to 0. Now in place of y, we have x minus 1 over 2, that is y, is equal to 0. So x, if minus 1 over 2 crosses the equality sign, it becomes positive. You can now say that therefore x is equal to 1 over 2 and y is equal to minus 1 over 2. So we're going to come back here to this point. So we have that t is equal to k L to the power of x and g to the power of y. So t is equal to k. Now we have that x is 1 over 2. So in place of x, we have 1 over 2. And g is minus 1 over 2. So and y is minus 1 over 2. So in place of the y, we have minus 1 over 2. So t is equal to, according to the law of indices, L raised to half will be square root of L. And because this is kind of a minus sign, this will become 1 over the square root of g. So t is equal to k root L over root g, and t is equal to k square root of L over g. So now we'll say let k be equal to 2 pi, because k can represent anything, is a constant. So t will be equal to 2 pi square root of L over g. So with this, we'll be able to derive, using dimensional analysis, we'll be able to derive the equation for the period. Yes, and this also tells us that that equation is correct if we were to test if the equation exists. So we can say hence the equation exists. Now this is very vital in physics for deriving equations. Even when we go deeper, when we start to treat wave and vibration, you see how we'll be deriving different equations using this dimensional analysis. So this is all for dimension. I think this wraps up the topic for dimensions. So in our next class, we are going to be looking at those quantities one by one. We are going to be solving problems under those quantities one by one. So I think we are going to start with two types of quantities, scalar and vector quantities, and we'll see how we can solve problems under them. So stay tuned for the next topic. It's going to be dealing on scalar and vector quantities, essential quantities in physics that we need to really put our minds around. Thank you for watching this video.